Hello everyone, I'm Alfian and today we are going to solve the HackerRank challenge on the data structure section called the insert a node at the head of a linked list. Just like yesterday, since the yesterday challenge it was about insert a node at the tail of a linked list. And for this particular challenge, it says given a pointer to the head of our linked list, insert a new node before the head. The next value in the new node should point to head and the data value should be replaced with a given value. Return a reference to the new head to the list. The head pointer given might be null, meaning that the initial list is empty. The function description complete the function insert node at head with the following parameters. Singly linked list node, which is the L list, called the L list parameter for the first parameter, and it is in the form of single linked list node or a node in short, and for the second parameter, which is the data in a form of integer. And for this function, expected data type of the node or the static function, and the function called the insert node at head. And input format, the first line contains an integer n, the number of elements to be inserted at the head of the list. The next n lines contains an integer each, the element to be inserted, one per function call. As you notice, the static function will be called per function, or per data will be changed over time. And for the sample input right here, we have five datas, which is the 383, 484, 392, 975, and 321. And the sample output, which is placed backwards from the last one up to the first one, which is from the 321, 975, 392, 484, 383, and that is the output. And the explanation is already declared out here, so let's see what the system out print line, or if you're working in JavaScript, using the console.log to see what is inside the linked list, using the linked list parameter variable right here, and check if it's null. And for the second system out print line, just like the HackerRank challenge from yesterday called the insert node at the tail of a linked list, then we need to do the same thing, just with more adjust approach, using the data right here to see what is the data contains, or if it's being printed 5 times, or in other words in backwards, or not. Let's return for now using the placeholder of the linked list as the return placeholder. Let's run this to see what it is about, and as you can see, we still have the output of empty, and the expected output is 3 to 1 from the back of the data number, which is reverse, and then 975, 392, and so on and so forth. And the debug output says true, everything is true, and the printed data is from the backwards to the first data right here. So since we are trying to insert the head instead of the tail, let's define our yesterday work to detail by creating a new singly linked list node. I just want to give a little reminder for you about how we are working with the tail instead of the head. Let me remind you by creating a new node, and then for this new node takes new constructor of the singly linked list node that takes the parameter of data, and the next one we can check if the linked list is equals to null, which it is. Let me draw something like a little visualization of what are we trying to solve. Like for the first linked list of the node, we have null value, and the next is, of course, there is no next because it's already null from the start. If it's in the form of node, then we can simply add a null to the singly linked list node of the next property of null. Since we already null from the start, then we are pointing null using the caret sign to point the current pointer to the null, linked list of null. Since it is, then the debug output is already printed true. Then of course we are going to assign a new node to the linked list using the return new node using the lowercase new node. I'm sorry, it's not new node, but just return new node, because new is already declared from the constructor of the variable new node. So let's run the code again to see what it's about from inserting the tail. And we have 383 as the first node, which is wrong, and the expected output is 321, which from the tail to the head. But the debug output has some changes, like this is true because the node is already exists, and the second one, which is false. And for the next iteration of the static function, is already assigned as the new node, and the rest of it is false, and the rest of the function returns false. And since the if already executed right here, and then the current state of the linked list will be placed as the new node right here, and the next one is of course equals to null of the next property from the new node right here, and it's still pointing to the new node. And how do we move this to the next one? We can simply use another singly linked list node called the current node from the previous challenge of inserting the tail. If you want to skip this part, then go ahead, but for the challenge, let me remind you about this. And we can assign the current linked list from the linked list parameter, and we are declare the current node like this, new node as the current node, new node, and then the next is null, and we have the current node as the pointer right here using the caret, and then called the current node. And we can check while the next node, which is the current node dot next, is not equals to null. As long as it is not equal to null, then of course we are moving the current node to the current node dot next, and then we are assigning, after we using the while loop, we are pointing to the first new node right here, and then for the next one we are pointing to the next node right here, and then the while loop will stop, and then we can assign the current node dot next equals to the new node, and that way we are assigning new node to the new node again, new node number 2 from the new node right here, and then the next one will be null, because the singly linked list node class right here is automatically construct a new property called data, and another slot for the singly linked list node called the next property. And for the return linked list is still returning linked list, and then for the next static function call, it's still pointing to the new node right here, but for the next one it is much more different. The new node will be pointing to the next new node of the null, new node, and then the next one will be null, and then the while loop will iterate the current node dot next, iterating the current node dot next again, and then it will be stopped at the null part right here, and then we are assigning the current node dot next with the new node until the data is empty. So let's run the code, and there you have it. We have the 383 484, but the expected output is in backwards. So how do we solve this? It is fairly easy. Let's delete this part by deleting everything starting from the first one. Let's comment this out, and starting from the first one by still creating the singly linked list node of the new node. The current state of the function right here before calling, it is already null from the start, and then we are assigning a new node, a new variable called the singly linked list node, data type of the new node, and then for the next one we don't have to check if the linked list is equals to null because it is already null, Then we can simply assign the new node dot next of the next new node with the current linked list, and that way we are assigning the, since the current linked list is already null, then we are assigning the new node dot next with the linked list, and then the current dot next is placed right here. Let me visualize this, and the new node, this is the new node, and the next is pointing to the null, which in other words it is visualized like this: new node is equals to null, and then it is still pointing to the new node dot next. I believe it's pointing to the new node dot next, and then we can assign the new node. We can assign new node to the, not assigning node, but we can simply return the linked list. Let's delete this part and let's run the code. And we still have the wrong answer. And don't forget to assign the new node with the linked list. So let's run the code. We still have the wrong answer. What about the linked list equals to node, new node? And there you have it. And let me explain this shortly. For the first state, we still have the null value right here that points to the null, It is before the function call of the insert node at head, and then we declare a new node, creating or constructing a new single linked list node with the value of data, contains the data. We are creating new data of, let me see, it is starting from 383. Since the data is 383, then we assign 383 as the node right here, as the new node, and then we are assigning the new node of the next new node to the next with the linked list right here. Since the linked list parameter already defined as null right here, already visualized as null, then of course it is pointing to the previous one, or to reverse the visualization, to minimize the confusion, we are assigning the 383 to the previous of the null right here, and then it is already automatically pointing to the new node dot next, because we are not declaring any more current node like we did on the insert node at tail challenge. So it is stays there, the pointer stays there of the current node. Then we don't have to declare the current node in using the while loop or anything short of that. Then we can simply assigning the current linked list of the new node right here. I assume this linked list, assign the new node to the linked list, assigning the new node to the linked list, already declared linked list. So that way we have a new state of the return linked list. Let's declare the linked list variable, since we're already declaring the linked list as the new node right here. Then of course we are pointing to the 383, and then the next one is already null. It is for the dot next property of the null right here, and then the new node is already pointed to the linked list. And then for the next one, since we already have the linked list value right here, then we don't have to check for the if the linked list is empty or null, because it is redundant, and we just simply declare another node called the 484. This is the second iteration of the insert node at head function, the function call, and then we are assigning the new node dot next of the current linked list. Then we are, since the linked list is already contain 383 and null, then of course we are moving 383 and null with the assigning with the current linked list as the new node dot next. Then we are assigning new node, and this is the next property. And since the new node itself already contains 484, then we are assigning the linked list of the new node to the new state of the linked list. Then we simply return the current state of the linked list to the for the next function call. And so let's submit the code. And I'm sorry for my bad explanation about this. I'm still beginner, just like everybody else. We are starting at some point, just like everything in life. So That's about it. I hope you understand my explanation. If you still don't understand, you can ask me in the comment section, or if you have better solution regarding this challenge, tell us what you think in the comment section. I hope you have a great day, and I will see you in the next video. And thank you for watching the video. Goodbye.